Hello students, this is a Maths Worksheet 19, chapter number 3, Playing with Numbers. Dear students, you also follow COVID appropriate behavior at your home. So you wear mask, follow physical distancing and maintain hand hygiene. So now here we will discuss about HCF, highest common factor. And in short, here we write HCF. Okay, so in the previous sections we have learned about factors and multiples of a given number. In this section we shall learn how to compare factors of groups of numbers and find the largest that is common to them. This is also known as their highest common factor or HCF. Okay, so what is the definition of HCF actually? The highest common factor of two or more numbers is the greatest or the largest among common factors. So here we write the definition of highest common factor. So the highest common factor HCF of two or more numbers is the largest or the greatest among common factors. Okay, so students, you also copy down this whole work in your fair notebook. Okay, so in the other word, the HCF of two or more numbers is the largest number that divides all the given numbers exactly. So now here I take some example related to HCF. Example like, here we find the HCF of 24 and 36. Here we find HCF of 24 and 36. Okay, so here first we find the factors of 24 and factors of 36. Now here we write factors of 24. So factors of 24 are, here we write directly like 1, then 2, then 3, then 4, 6, 8, 12 and 24. Why we write 1, 2 and these all factors? Because if we multiply 1 and 24 we get 24. So 1 and 24 is the factors of 24. Then 2, 12 2s are 24. So here 2 multiplied by 12, here we get 24. Then 3 multiplied by 8, 3 8s are 24, and 4 6 are 24. So these are the factors of 24. Now here we find the factors of 36. Factors of 36. So what are the factors of 36? So factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. So when we multiply 1 and 36, we get product 36 here. So 1 and 36 are the factors of 36. Now we multiply 2 and 18, then we get product 36 again. It means 2 and 18 are the factors of 36. Now 3 and 12, we multiply 3 and 12, we get product 36 here. So 3 and 12 are the factors of 36. Now 4 and 9, if we multiply 4 and 9, then we get product 36. So 4 and 9 are the factors of 36. Now 6 and 6, if we multiply 6 and 6, we get product 36. So 6 is a factor of 36. Okay, so now we find the common factors here. Here we write common factors. So what are the common factors of 24 and 36? So the first factor is 1. So here we write 1. Second factor is 2. So here we write 2. Third factor is 3. So here we write 3. Then 4, 6 and 12. So 1, 2, 3, 4, 6 and 12 are the common factors of 24 and 36. Now out of these all common factors, we find that 12 is the greatest. Okay, so out of these all factors, 12 is the greatest. So here we write the HCF of 24 and 36 is 12. So now here we write HCF of 24 and 36 is 12. Okay students, so students, the highest common factor is also called the greatest common divisor, in a short GCD, or greatest common measure. Okay, so here you also write this statement: the highest common factor is also called the greatest common divisor. And in short, here we write GCD, or greatest common measure. So these are the other name of HCF. Okay, so HCF of two co-prime numbers is always 1. Okay, so here we write HCF of two co-primes numbers is always 1. Okay, so HCF is also known as or called the greatest common divisor, because the number which we get as a HCF is divide these both the given number exactly. Okay, so there are two commonly used method for finding HCF of two or more numbers. The first one is prime factorization and the second one is continued division method. Okay, so here we write there are two commonly used method for finding HCF of two or more numbers. The first one is prime factorization method, and the second method is continued division method. Okay, so now here first we will discuss prime factorization method of two or more numbers. So now here we will discuss prime factorization method to find HCF of two or more numbers. Prime factorization method to find HCF of two or more numbers. Okay students, now we take one example here related to this method, and here we follow some steps. So find HCF of 20 and 48 by using prime factorization method. Okay students, so dear student, what we do here basically, first we find the prime factors of 20 and after that we find the prime factors of 48 here, and after that we take common factors. Okay, so here first we write the prime factorization of each of the given number. Okay, so now first we take number 20 here, and the second number is the second number is 48. Okay, so here first we divide this 20 by 2. So 2 tens are 20. Okay, then again 2 fives are 10, and then by 5. 5 ones are 5. Okay, now for 48, first we divide this 48 by 2. 2 twos are 4 and 2 fours are 8. Then again divide by 2. 2 ones are 2 and 2 twos are 4. Okay, then again divide by 2. 2 6 are 12. Then again divide by 2. 2 3s are 6. Then 3 is not divisible by 2, so here 3 divide by 3. 3 ones are 3. Now we write the prime factors of 20 and 48 here. So 20, 2 into 2 into 5. So here we write 2 multiply by 2 multiply by 5. Then 48, 2 multiply by 2 multiply by 2 multiply by 2 and multiply by 3. So we write 2 multiply by 2 multiply by 2 multiply by 2 multiply by 3. Now here find the common prime factors here out of these all factors. So here the first pair is 2 and the second pair is 2 here. So now here we take here 2, then multiply by 2. Here we take only common factors out of these all factors. Okay, so here 2 twos are 4. So here we say that HCF of 20 and 48 is 4. Okay students, now here we take another example. Sample number 2. Find the HCF of 144 and 192 by prime factorization method. Okay, so here we apply the same rule here. First we find the prime factors of 144 and 192. So here first we write prime factorization of given numbers. So here first we find the prime factors of 144, and after that we find prime factors of 192. Now first we start from 144. So here we divide 144 by 2 because 144 divisible by 2, and you all know that what is the rule of divisibility, rule of 2. If the last digit divisible by 2, so the whole number divisible by 2. So here 2 7s are 14 and 2 2s are 4. Now 72 again divisible by 2. So here 72 divided by 2. 2 3s are 6, and here 1 is left here. So this number form 12, 1 and 2. 12, 2 6 are 12. Now then again divide by 2. 2 1s are 2. Here 1 is left here, and 1 and 6 form 16. 2 8s are 16. Then 18 divide by 2. 2 9s are 18, and 9 divide by 3. 3 3s are 9, and 3 only divide by 3. 3 1s are 3. Okay, now for 192, first 192 divide by 2. So 2 9s are 18, and 1 is left here. So 1 and 2 form 12. 2 6 are 12. Now again divide by 2. 2 4s are 8. 1 is left here. 1 and 6 form 16, and 2 8s are 16. Then again divide by 2. 2 2s are 4, and 2 4s are 8. And again divide by 2. 2 1s are 2, and 2 2s are 4. Then again divide by 2. 2 6 are 12. Then again divide by 2. 2 3s are 6. Then 3 is not divisible by 2, so here 3 divide by 3. 3 1s are 3. Now we write all factors. Now here we write all factors of 144 here. So 2 multiply by 2, multiply by 2, multiply by 2, and multiply by 3, and multiply by 3. So here 2 repeat total 4 times, and 3 repeat total 2 times here. Now for 192, here 2 repeat 1 2 3 4 5 6 times. 1 2 3 4 5 6 times, and 3 repeat only 1 time here. Now we take common factors, okay, common prime factors out of these all factors. So here first 2, then again 2, then again 2, and then again 2. So here 2 repeat total 4 times as a common, and now 3 as a 1 time here. So here we write 2 multiply by 2, multiply by 2, multiply by 2, and multiply by 3. Now we multiply these all prime factors. 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 3s are 48. So here we write, therefore the HCF of 144 and 192, okay, is 48. Okay, so now students, here we will discuss the next method, continued division method. Okay, so here we will discuss the next method, continued division method. Okay students, okay, or this method also known as Euclid's algorithm. Okay, so now here we take one example related to this question. So Euclid, a Greek mathematician, devised an interesting method to find the HCF of two numbers. So basically, here we not write the complete steps as like an algorithm, but here we solve using continued division method. Okay, so here we follow these steps only. So here we take first example here. Okay, so here find HCF of 24 and 36 by using Euclid algorithm. Okay, so according to Euclid algorithm, here first we find the greater number, and here we select greater number as a dividend and smaller number as divisor. Okay, so which one is greater number here? 24 is smaller and 36 is greater here. So here we write, we have dividend equal to 36 and divisor equal to 24. Now we continuously follow the divide process to find HCF. Okay, so here we write dividend and here we write divisor. So now how many times 24 divide 36? One time. Okay, because 24 2s are 48. So 24 1s are 24. Now we subtract these two numbers here. 6 minus 4 2 and 3 minus 2 1. Now here 24 is divisor here. Now 24 is divisor here. So now here we take 24 as a dividend and this remainder 12 as a divisor. Okay, so student, here again, here we take 24 as a dividend here and this remainder 12 as divisor. Now how many times 24 divided by 12? 12 2s are 24. 24 minus 24 0. So here we write, because the last divisor is 12 here, and Euclid algorithm say that the last divisor is the HCF of the two given numbers or the given numbers. So here we write clearly the last divisor is 12. So we write hence the HCF of the given number is 12. Okay students, Here you will remember one thing, especially the last divisor is the HCF of given numbers. Okay, and you take here divisor as a dividend, here a remainder as a divisor. Okay, so now here we take another example. Find HCF of 513 and 783 by using continued division method. So here you all know that here we take the greater number as dividend and smaller number as divisor here. So here we write dividend 783 and divisor 513. Okay, now we start process of division here. 783 divided by 513. So 513 divides 783 one time. So here we write 513. Now we subtract these two numbers here. 3 minus 3 0, 8 minus 1 7, and 7 minus 5 2. Here we again follow the same process. So here 513 is divisor here. So here we take 513 as dividend and this remainder 270 as divisor. Now 270 divide 513 one time because 2 times is greater. So here we write 270. Now we subtract these two numbers here. 3 minus 0 3. Now 1 is smaller as compared to 7. So here we take one borrow from 5. Here 4 is left here, and here 1 change into 11. 11 minus 7 4, and 4 minus 2 2. Now again we take 270 as dividend here and this remainder 243 as divisor. Now 243 divide 270 one time. So here we write 243. Now we take one borrow from here. So 10 minus 3 7, and 6 minus 4 2, and 2 minus 2 0. Now we follow the same process. Here we take 243 as dividend here and 27, this remainder 27 as divisor. Now 27 divide 243 9 times. 27 9s are 243. So here we get 0. So now here we write clearly the last divisor equal to 27. Okay, so here we write one more line here. Hence the HCF of the given numbers is 27. Right friends, here I solved some other questions related to HCF. Now the question is, find largest number which divides 245 and 1029 and leaving remainder remainder 5 in each case. So what we do here, it is given that the required number when divides 245 and 1029, the remainder is 5 in each case. This means that here we subtract 5 from 245 and subtract 5 from 1029. So here we get, when we subtract 245 minus 5, we get 240 here, and here we get 1024. Now here we compare these two numbers. Which number is greater? 1024. So here we take 1024 as a dividend here. Okay, so here we write 1024 and divisor equal to, here we write divisor equal to 240. Now we divide 1024 by 240. So here we start this process. Okay, so now here we write 1024 divided by 240. So how many times it's divide 1024? 4 times. So when we multiply 240 by 4, we get 4 zeros are 0, 4 fours are 16, 6, 1 carry here, 4 twos are 8, 1 9, 960. So here we write 4 and we subtract 960 from it. So 4 minus 0, 4. Here we take 1 carry here. So this number change into 12. 12 minus 6, 6 here, and 9 minus 9, 0. Now, so here we take, because 240 is divisor here, but here we take as a dividend, and this remainder 64 take place as divisor here. Okay, so now how many times 64 divide 240? So here, so 64 divide 243 times. 4 3s are 12, 2, 1 carry here, 6 3s are 18, 1 19, 192. So here we write 3 here and here 192. Now we subtract these two numbers here. So here we take one borrow, so this number change into 10. 10 minus 2, 8 here, and here 13. 13 minus 9, 4, and here 1 minus 1, 0. Now here is 64 and 64 is divisor here, and here 64 take place as a dividend. Now 48 divides 64 one time. Now here we subtract this number. So 14 minus 8, 6, and 5 minus 4, 1. Okay, now here we write 48 here, and how many times 16 divide 48? 3 times. 16 3s are 48. Now 48 minus 48, 0. So here we write, because you all know that last divisor is the HCF of given two numbers here. So here we write clearly HCF of 240 and 1024 is the last divisor, that is 16. So here we write hence required number is equal to 16. Okay students, now we take a next question here. Find the largest number that divides 2053 and 967 and leaves a remainder five and 7. Respectively. Now it is given that on dividing 2053 by the required number there is a remainder of 5. This means that here we subtract 5 from 2053 and here we get 2048. Now in the second number 967, here we subtract 7. So 967 minus 7, we get 960 here. Now we compare these two numbers here. Which number is greater? 2048. So here we take 2048 as a dividend. Okay, and as a divisor 960. Okay, now we divide greater number from smaller number. So how many times 960 divide 2048? 2 times. So 960 multiply by 2. 2 zeros are 0, 2 6 are 12, 2 1 carry here, 9 2s are 18 or 2 9s are 18, 1 19, 1920. So here we subtract 1920 from 2048. Okay, so 8 minus 0 8, 4 minus 2 2, take 1 carry from here and we get 128. Now we take 960 as a dividend here and 128 divide 960 7 times. So 128 multiply by 7. 7 8s are 56, 6 5 carry here, 7 2s are 14 and 14 plus 5 19, 9 1 carry here, 7 1 just 7 and 8, 896. So here we write 7 here and here we subtract 896 from 960. So now we subtract these two numbers here. Here 5 is left here and here 0 change into 10, 10 minus 6 4 and here 5 is there. So here we take one borrow from here. So this 5 change into 15 and 15 minus 9 6, 64. Now we take 128 as a dividend here. Now 64 divides 128 2 times. Okay, so 2 4s are 8 and 2 6 are 12. So 2 times here we get 128. 128 minus 128 0. So now you all know that the last divisor is the HCF of the given number. So here we write clearly HCF of 960 and 2048 is the last divisor, that is 64. So here we write hence required number equal to 64. So by using this method you find the required number.